So in this video I'm going to show you how to prepare a gel. And this is nice because I get to show you some of the glassware that we use and some other instruments that we use as well. So I'm going to start off, hopefully you've got your procedures out so you can kind of follow along with me. I'm going to start off by making the TAE buffer. This is a buffer that we're going to use to prepare our gels and also when we run our gels. So it's going to go in the electrophoresis chamber. What I have going on right now, if you can see that, I've got an Erlenmeyer flask here, and I can take it right off of here. And this just has water in it, deionized water. It's got 980 milliliters. Okay, so you can see on the Erlenmeyer flask there is measurement here on the side. I did use a graduated cylinder to make sure that I had exact measurements. Okay, so again, it's 980 milliliters of deionized water. And what I have here in the bottom is a stir bar. It's a magnetic stir bar. I'm not sure if you can see that. It's a little white right there, white structure. And so when I put it onto my stir plate here, and I plug my stir plate in, you can see that now it's spinning. And what I'm doing is I'm mixing. Okay, so it's just a nice, convenient way to mix our solution. Now, the buffer here, that comes from Biorad, which is the company we use. We purchase all of our DNA and things from that we are going to use in this lab. It sends us this buffer 50x, so 50 times concentrated. We need to get it down to a level that we want to use it at. So what we're going to do is we're going to take 20 milliliters out of here, and we're going to add it to our deionized water. We're going to let it spin, not too hard. I got it kind of up there, and just to stir it up a little bit before we use it in our gels. Okay, so to get 20 milliliters out of here and put it into my Erlenmeyer flask with my water, I could use a graduated cylinder, but I'm going to be a little bit more careful here because I have my computer out. I don't want to be pouring and spilling, so I'm going to use a pipette, which is nice. Okay, this is a graduated cylinder. Hopefully you've seen those before. Okay, I use this to measure out my water in there. This is a 100 milliliter graduated cylinder. But again, I'm going to go ahead and use a pipette just to show you another instrument, and also so I don't have to pour anything. Okay. Now, you guys have not had me live this semester, but if you did, you would know that I'm a little bit clumsy, and I'm not very good with gloves on. However, you want to wear gloves when you work with this TAE buffer, and also protective eyewear. And, you know, also a lab coat would be a good idea. I gotta take the glove off. Okay. So we'll pop this open. This is a disposable pipette, and it's being finicky on me here. Just rip it. There we go. Okay. Okay, and I'm not too worried about sterility here, but I don't really want my DNA all over anything. So I'm going to wear my gloves, and I'm going to try to be as careful as I can. I did just wash my hands as well. So I'm going to pop this open. And my pipette here is a 10 milliliter pipette. So I'm going to have to fill it twice because I want 20 milliliters. This right here is called a pipette bulb. And you may have seen these before. If you had me for GB1, we may have used them in the lab. Okay, this is going to be what's going to suction up or draw up the liquid. So I'm going to go ahead and I'm going to attach it to the end of my pipette. And there we go. I'm ready to use it. Okay, you can see the tip on there. I'm going to put the tip of the pipette into the bottle. On my pipette bulb, I'm going to hit the S button, which stands for suction, and that's going to draw liquid up. Okay, so hopefully you can see that coming up here. I'm going to go all the way to the 0 mark, which is 10 milliliters. Okay, I'm going to wipe off the side so I don't have any residual. I'm going to go ahead and shoot that right in there. I'm not putting my tip in the water because I'm going to keep this buffer after, and I don't want any water in it. Okay, so again, I'm going to put 10 ml. And I'm going to dispense it right in here. Now this time I am going to touch the water because I'm done. Okay, so I just put 20 milliliters of my 50x stock solution into my water here to make a 1x concentrate. Okay, and I just drew it up and then back down just to clean anything out of that pipette that could have been residual. And I'm going to go ahead and put it right back into the sleeve, pop my bulb off, and I'm done with that. Okay, let that stir for just a minute to make sure everything is mixed before I go ahead and I make my, prepare my agarose for my gel. I'm going to pop my gloves off. Yeah, I'm going to have to pop my gloves off for this. Okay. The next thing I'm going to do is I'm going to set up my gel casting tray so that once my agarose is made, which I didn't make yet, I'm going to make it, I'm going to pour my agarose into this casting tray to make my gel. Now, I told you I'm a little clumsy, so what I'm going to do is I'm going to actually set up 2 gels. Even though we only need 1, I'm going to set up 2 just in case one rips or I drop it or I go through it with my pipette. You never know. So what do we have here? This is a plastic casting tray. So the gel boxes that we have, they're a little bit old. There are newer versions, but they work just fine. These are the casting trays that work with our gel boxes. Okay, so what we're going to be doing eventually is we're going to pour agarose onto here, and then this is going to be our gel where we're actually going to run our DNA onto, okay, or through, I should say. So before I put agarose on here, you'll notice that the edges are open. Okay, that's important when you run your gel. You want to have edges that are open because you want current to flow through the gel. But when you're pouring it, you don't, because if you pour it, it's just going to pour off the side. So we're actually just going to use regular old masking tape to block the sides. But before I do that, I'm going to put on here a glass, piece of glass. And this is going to help after we are done running our gel and we go to stain it. We got to take the gel off of here. And this is, agarose gels are kind of gelatinous, thin, and kind of easy to rip. And so this is going to provide a nice, hard, flat structure that the gel is going to sit on so that we don't tear it or rip it when we're trying to take it off. So that glass is just going to line right up there on our casting tray. You're not even going to be able to see it. Okay? And again, I have 2, so I'm going to do the same thing over here. I'm going to put my piece of glass right onto that casting tray. Now I'm going to tape off both ends. So again, I'm just using regular old masking tape. And I'm going to tape off both ends. Okay. So there, I've got one end taped off of one. So see, I just taped it off so again, once I pour, it doesn't just go right out the edge. Okay, and you can see these aren't going to be very thick. They're going to be pretty thin, and again, kind of flimsy. Even once they're, completely solidified, they're still kind of gelatinous. Okay, remember, an agarose gel is going to work like a molecular sieve. It's a polymer, and what's going to happen is our DNA is going to travel through that, and the larger the DNA, the farther it's going to travel in that agarose gel. So, larger fragments of DNA are going to travel farther down in the gel than smaller fragments. Or sorry, that's the opposite. I'm trying to tape this while I talk. So the smaller the fragment, the farther it's going to migrate on the gel. The larger the fragment, the closer to the top of the gel, the wells. Okay, smaller fragments are smaller, so they can squeeze in between the molecules of the agarose gel, that polymer, a little bit easier than the larger molecules. So again, because I botched that up, let's say it again. The smaller the DNA fragment, the farther it will migrate in the gel. Okay, so I've got both ends taped off, hopefully well. Now what I'm going to do after I pour my agarose, my melted agarose into here, I'm going to stick in what's called a comb. And I want to show you this now because I have to do it so quickly later. So that comb, after the agarose is in, is going to lock right in place right there. Let me pull it back out again. Do you see the teeth on that comb? That is what's going to create the wells, the indentations, where we're going to load our DNA samples. And so the wells, again, is where the DNA sample sits, and that's going to be the very top of each lane. Okay, so this particular comb, I think, creates 8 wells. I think there's 8 little marks on there. Okay, so we're going to be able to load, we only have 7 samples of DNA, but if we had 8, we could load 8 on there. Okay. Okay, I'm going to go ahead and tape off my second one. And while I'm doing that, I'm going to pause this and I'll get my Agarose set up so that we can come back and I can show you how to make that. Okay, so I've got my casting trays all taped off, and I've got my Erlenmeyer flask here now with 300 milliliters of my 1X TAE buffer, so the buffer that I just prepared. And now I'm going to add to that 3 grams of Agarose. And so Agarose comes as a powder, okay? And again, I have to put that into solution and melt it, so it's going to be molten agar. And so what I have here is a stir plate as well as a heat plate. So I'm going to spin this liquid and I'm going to heat it up to get this powder to go into solution and then to get it to be molten. Okay, and then I'm going to let it cool for just a second before I pour it. I'm going to actually pour it into a beaker first, because I like to pour from a beaker because it has this nice pour spot where the Erlenmeyer flask does not. I like to heat in the Erlenmeyer flask because of the shape. This will start to bubble up when it boils, and if I had a beaker, I have a greater chance of having it kind of boil over. And so it's just kind of safer to use my Erlenmeyer flask. So what I'm going to do now is I'm going to start to stir. And again, I'm going to stir, not too fast, but not too slow. And then I'm going to start to apply a little bit of heat. So I've got stirring happening and I've got heating happening. And now I'm going to take my Agarose, which I have in my little weigh boat, again 3 grams, and I'm just going to pour it in kind of carefully. Okay, so you'll see now that this is very opaque. I can't see through it. What's going to happen as this starts to heat and that Agarose starts to go into solution and become molten is it's going to eventually turn clear. And I'm going to actually kind of let it get it almost to a boil and then cool it and then boil it and then cool it a couple of times until I get it nice and clear. And then I'm going to go ahead and I'm going to let that cool off just a tad. I don't want it to solidify, so just a little bit. And then I'm going to pour it into my beaker and then I'm going to pour it into my gel. I'm not going to make you sit here and watch this because it's going to take a little while. What I am going to do is I'm going to hit pause, and then when I'm about to pour, I'm going to go ahead and turn our camera back on so that you can see that process. So I'll be right back. Okay, so my Agarose has finally gotten to the point where it's kind of boiling in there, right? So I'm going to go ahead and remove it from the heat, and if we get rid of those bubbles, again, I've let that come to a little bit of a boil and then cooled it and then boiled it and then cooled it a few times, and you can see that it's the opaqueness is gone. It's pretty clear. So again, I need to cool it for just a second before I pour it into my casting trays. And as soon as I pour it into my casting trays, I'm going to go ahead and stick the comb right in there. Okay. So again, I don't like to pour from the Erlenmeyer flask, so I'm going to pour it into my beaker here carefully. And again, I want to let that cool for just a second. And then once it's cool, I'm going to go ahead and I'm going to pour it into my casting trays. And once I have it in, I'm going to stick my combs in. And then it's going to take a little while before they solidify into that nice gelatinous Agarose gel that we like to run our DNA on. And while I'm waiting for these to solidify, I'm going to start my DNA sample prep, which actually I already have kind of going on in front of me. I'm going to make a separate video showing the DNA sample prep. There is some behind the scenes work before we can actually prepare our samples to run in a gel. So I'll show you this tube right here. This is DNA from suspect 3. And I don't know if you can see at the bottom of this vial, this is a glass vial with just a stopper on it. It comes with a metal piece that kind of seals it off. But at the bottom here there is lyophilized or dried out DNA, and you can see it's white, just like the DNA that you extracted from strawberries and from kiwi last week. If you kind of dried that out, this is what it would look like. So we're going to get this DNA into solution, and then it's not going to be white anymore. It's going to be colorless. So once DNA is in solution, you can't actually see it. So I'm going to go ahead and I'm going to add 200 microliters of water to each of these DNA sample tubes. I'm going to kind of flick the bottom to mix it up, and my DNA will be in solution. This is what we're going to use in the next step. We've got DNA from the crime scene and from 5 suspects. Okay? Okay, let's see. I think that's cooled off enough. I always say if I can touch the glass, it's probably good. Okay, so again, I'm just going to kind of carefully pour, and I want to be careful to not overfill them, because then they're going to overflow. It's kind of a little bit of a science to this. Okay, so again, I'm just going to tilt my beaker to the side, slowly pour. The slower that you can pour, the less likely you are to get air bubbles in here. We don't want any air bubbles. And I want to make sure I fill it all the way to the top. Okay, hopefully without going over. Before I pour my second one, I do have some air bubbles forming in here. I'm just going to use the edge of my comb to try to get those out. Not a huge deal. I'm going to get a little bit more in here. Okay, and then again, I'm going to put my comb in gently. Remember, the comb is what is going to create those wells, which is where we're putting our DNA. So there's one gel all poured. Got a little bit on my finger, burns a little. And here's my second gel. Okay, again, I'm pouring two just in case I rip one. But I'm only going to probably run one. And again, the air bubbles tend to form underneath these plates, and I like to get them out before so that they don't come poking out after. Okay, I'm just going to pour a little bit more. So for those of you who are bio majors, hopefully at some point you take a course where you actually get to do this yourself. A biotech course. Or maybe when you go on to do your graduate work, maybe if you're working with DNA, you'll get to do that. So again, I'm going to let these sit. So they're in. The agarose is poured in. It's still hot, so it's definitely not solidified yet. And I put my combs in. My tape held up pretty nicely, so it didn't pour out the sides. And so now I'm going to let these sit on my bench top, for about probably a half hour, 45 minutes. They're probably going to sit longer than that because I'm going to get all the DNA prep work done while they're cooling. And then I can go ahead and I can use them. Okay, so we're going to come back to these in a little while. You're going to want to go ahead and you're going to want to watch the next video, which is on the preparation of our DNA samples.